Hello once again. This is another uh, problem from production. This is a Cobb Douglas function. So you are to estimate or calculate the marginal product of labor and marginal product of capital. Then you also calculate the marginal rate of technical substitution of labor for capital, and of capital for labor. Now, this this is another. It's a simple calculations. You just go step by step and remember some of the small rules of indices and differentiation. So let's go. What we do first, we try to we bring down the equation, which is the main function, which is x equal to a l raised to power 0.8 k raised to power 0.2. Now, your MPL and your MPK, which is marginal product of labor and marginal product of capital, is the same thing as the differential value of the equation, the function x, with respect to L, and MPK is equal to the differential value of the same equation x, but this time with respect to k. So we start by finding the MPL. When you differentiate the x with respect to L, what do you have from the equation? Since you are differentiating with respect to L, others will remain. So what you have is the power of L 0.8 will come down, this time around to multiply AL raised to power 8, but of course minus 1, because when you differentiate, you reduce the power. So this is what you're left with. Then there's something that happens here with the law of indices. This becomes like this, minus 1. Okay. Then you can go further to make it 0.8 AL raised to power 8, 0.8 multiplied by k 0. Raised to power 0.2. You take that L with raised to power minus 1, take it outside of the bracket. Now, what happens is that recall from your initial equation, AL raised to power 0.8 multiplied by k raised to power 0.2 is actually x, equal to x from the beginning. Recall this. So since that is the case, the x, the L, which is your MPL, is equal to 0.8. Now instead of having AL raised to power 0.8 multiplied by K 0.2 in the bracket, you simply have X. You replace it with X. Now L minus 1. And with the simple law of indices, your L minus 1 is the same thing as 1 over L raised to power 1. So that's like multiplied by 1 over L raised to power 1. You don't have to write it. So you have 0.8x all over L. You can, that is your MPL. You can leave it like this, or you can go further to explain that x over L, x over L is actually APL, which is average product of labor. It is average product of labor. It is average product of labor. Of labor. Now, so you can have MPL equal to 0.8x all over L, which is the same thing as 0.8 APL. So either of these, you are good to go. You go further again to derive the MPK, which is also the same thing as the X decay. So when you differentiate the equation X with respect to K, that means you are only going to take the power of K this time around. You don't have anything to do with that of L. So 0.2 will come outside, the bracket will open. You have this 0.8 multiplied by K raised to power 0.2 minus 1. Then the same thing that happens earlier, you try to split that minus 1. So AL will just remain as it is. Now you have 0.2 and you have K minus 1. You close bracket. So the next thing is to factor out the K. So you have A into L, raised to power 0.8 divided by K raised to power 0.2. You take the K raised to power minus 1 outside. Recall, as usual, that AL raised to power 0.8 K multiplied by K raised to power 0.2 is equal to X. So in that case, your MPK is equal to 0.2 X multiplied by K raised to power minus 1, which is the same thing as 0.2x multiplied by 1 all over K. You have 0.2x all over K. Also, note that x all over k is equal to APK. Is equal to APK. Therefore, your MPK is equal to 0.2 x over k equal to 0.2 APK. So you can leave like this. You can leave, where is the other one? You can also leave this like this. So that is your MPK and that is your MPL. That is your MPK and that is your MPL. Now, let's go back again. The next question now is for us to derive the marginal rate of technical substitution of labor for capital and of capital for labor, which is the rate of substitution of the input, one input for another. So to do that, your marginal rate of technical substitution of labor for capital is your marginal rate, your marginal productivity of labor and the marginal product of capital all over marginal product of capital. So you divide the MPL by MPK. That is how you get your marginal rate of technical substitution of L for K. The marginal rate of technical substitution of K for L, which is capital for labor, is MPK divided by NPL. So for marginal rate of technical substitution of L for K, you have your MPL all over MPK, and your MPL is from the other calculation. Don't use the one that has APK, APL and APK. So you just use 0.8x all over L all over 0.2x all over K. So what you do is you bring them up. This is L, not 4. This is L. So you have this. Now, since you are going to multiply, as they are coming up, they change. So you have K now as the numerator, X. So this is what you have now. So you can multiply everything. You have 0.8xk all over 0.2xl. So x can actually take away x, and you can divide 0.8 by 0.2, and you will have, can divide 0.8 divided by 0.2, you have 4. So 4 multiplied by k over L. This is your marginal rate of technical substitution of labor for capital. Now, you do the same thing for marginal rate of technical substitution of capital for labor, which is now MPK all over MPL. Now, what you do the other time, you just interchange them again. This time around, 0.2x all over k all over 0.8x over L. So From there, you have 0.2x all over k. Now, when this one, the denominator is going up, then L becomes the denominator of that fraction. The numerator of that fraction, then 0.8x becomes the denominator. So you can multiply them through just like you did the other one. You have 0.8x k. The x can take away the x. So when you divide 0.2 divided by 0.8, you have 0.25. 0.25 L all over k. Of course, this 0.25 is also the same thing as 1 over 4 L over k. And you can even have it like this, L all over 4k. So that is marginal rate of technical substitution of capital for labor, 0.25 L over k. Now, this is just the beginning of a very long journey. But if you are just asked to derive marginal product of labor and marginal product of capital, and the marginal rate of technical substitution, and of labor for capital and of capital for labor, without any figure given to you, this is where you stop. But if, for instance, another question is asked and it says, if A is given as 50, maybe 50 or 20, and L is given as 150, and K is given as 100, then you are to now find, this time around, you have to find MPL, MPK, MRST, L for K, MRST, for L. Now, this is a different section of the question entirely, so it will also take another steps and so on, beginning from your initial model like this. So of course, with this, when you derive this, then you can substitute them into the MPL, MPK, and the rest, and you get the value. So, but this section will be handled in another video. So thank you very much. Keep subscribing, keep watching, and expect more.